All right, a little bit about MuleSoft. So MuleSoft was started as an open source project with the mission to help organizations change and innovate faster by making it easier to connect applications, data, and devices. This is why we love to choose open source tools that allow us to help our developers innovate faster so that we can live to this mission statement for our customers. So a little bit about some of the scale that we're dealing with at MuleSoft. In our largest AWS production account, we're running 15,000 plus instances because we're actually running a lot of our customer code there. We have 20 plus AWS accounts that we need to deploy into. We're deployed globally into pretty much every region within AWS. And we're also in environments such as GovCloud. We've got an EU platform. And we also provide an on-premise product. We have many services because we operate on a very microservice type of architecture. And with Spinnaker, we're doing hundreds of bakes a day. So this is just a little bit of a view of our platform. Everything in black is our management plane, which manages all of the Mule runtime, which is our customer code. Spinnaker is powering all the management plane, and we have some new services right now running in Kubernetes.
So just to give you like a little taste of like what life was before Spinnaker, we had a deployment platform basically that was developed before Matt and I joined the company. It was run by the DevOps team, and basically the pipelines were built all around Jenkins. The pipeline would consist of Terraform, of course. Everyone uses Terraform to manage artifacts in AWS, but it would be everything. Like it would be not just the network infrastructure, not just the stateful services, but also they would deploy the instances using Terraform as well. And the way that would work was basically they would be deploying the base AMI that we would bake, and then they would use a salt role and salt stack to provision those instances based on the salt role applied to those machines. So instances would basically be all the same. They would boot up, they would talk to Salt, figure out what their role was, pull down the required application tarballs, pull down their configuration, and then get their secrets from the Salt pillars. And we had a sort of like a blue-green deployment strategy. It was kind of a Jenkins pipeline that used ELB health checks, and it worked, but it was not to the level of like what Spinnaker provided us. Another kind of like pain point we had was developers didn't really have a good way of getting secrets into the Salt pillars. So DevOps was like very handhold. They were kind of there to basically take secrets from the service owners, put them where they needed to be, and so getting your application deployed in this old method of in this kind of like legacy deployment method was like a very involved process. So when Matt and I joined the company, we were put on the core platform team, but we were actually given the task to improve the legacy deployments. And so what we did was we worked with some people from DevOps, we worked with some of our software architects, and what we decided to do was set up like a problem statement of what was wrong with our deployments at the time. So just the gist of what was going on was that our deployment workflow was focused on configuration management and software-defined infrastructure, which were good things, but it was lacking in being able to be a highly available deployment workflow. So like our blue-green deploys were not very mature, and they weren't. You still had to be like there to handhold it and make sure everything went well. We had our biggest thing was we only did Saturday deploys. So we had very strict SLAs with our customers, and due to like the fact that our application and deployment workflow was not that mature, we were kind of forced to do Saturday deploys, and that was basically a full Saturday with a lot of coordination, a lot of teams, basically not just DevOps teams, but also the software teams themselves had to be there to kind of coordinate and go through all the different deploys. So we had this problem statement, and luckily we were able to get in touch with the guys at Armory. They knew our director of IT, or director of infrastructure from a previous relationship, and they kind of came along and they said, hey, we understand your pain points. We've helped all these other customers before. We want to introduce you guys to Spinnaker. Why don't we do a proof of concept, show you how it works, and you can try deploying your AMI-based deploys using Spinnaker. So they came and they basically promised us, 24/7 support of the Spinnaker platform that they deployed. Provided a consistent release cadence of their version of Spinnaker, and then they also promised to help build out some of the feature requests that we had, namely New Relic integration, Jira integration, and then we also wanted to, this was about a year ago, so we were still waiting on Kubernetes and Helm support, proper Kubernetes and Helm support from Spinnaker to possibly handle our Kubernetes workloads. And then kind of like from our problem statement, this is kind of what we hoped to get out of it, was like our eventual outcome was that developers would no longer be dependent on cloud ops or DevOps to build and deploy their application packages. Spinnaker would remove those barriers that kind of prevented or kind of enforced us to have Saturday deploys. That was like our number one metric, was how many Saturday deploys or how many people are working on Saturday, because DevOps was sick and tired of it, and it's like everyone's on call on Saturday, so it was like a big deal. And we had it's like bi-weekly Saturday deploys, which pretty much we deployed every single application. So it's like, hundreds of services every other Saturday. So at a high level, our deployment pipelines will have like opinionated pipelines, easy integration to our test suites, and with the eventual hope that we would get automated approvals from those test suites. Several deployment models, so not just red, black, or blue, green, but also canary deploys. And then we were hoping, and the idea was to get the AMIs to be our immutable deployment artifacts, and not, before we had like a base AMI, and then and that was not even immutable because it was like downloading and reconfiguring on boot. So, but yeah, that was our eventual outcome.
So now we're going to talk about a little bit on how we onboarded the services, because pretty much within a year we were able to onboard every single stateless service at MuleSoft onto Spinnaker. So it required a team of 2 engineers, which is Sohail and I, that we brought up the host, the infrastructure, we managed the caching, we owned all the configuration within GitHub. We developed Packer configurations, base AMIs, for our developers to be able to use Spinnaker very quickly. And then we had help from the 2 DevOps engineers to manage the Salt configuration and secrets management, which we ended up going with Vault within our build environment, but then we're still using Salt for secrets within every other environment just because of the legacy. We also had to adjust our build scripts that we have provided for our engineers, and that would simply create their artifact, which was RPMs, because we were running on Amazon Linux. So we had 100+ services that we needed to be onboarded within a year. It was a pretty big mandate. The entire company was involved. From the top down, it was basically, let's get this done. Let's get some maturity into our development workflow. We needed it to be in every major environment, including GovCloud. So we have quite a few environments for testing, performance, QA, etc. We moved to an AMI-based installation bake. Instead of pulling down tarballs or using Salt to mutate the state, we thought RPM-based was perfectly fine, and we used the Nebula plugin from Netflix, which allowed it to be built into our Gradle tools. So why? Deployments were very involved, limited to deployment windows. Certain applications were mature enough to move to CI/CD, but the workflows were actually not ready to handle it. Service owners lacked ownership and visibility into their deployments. A lot of time was also spent by the DevOps team maintaining and firefighting all this infrastructure, so there was no real time to improve any of the processes that we had in place. Testing and rollbacks were also something that didn't exist. Testing did exist, but it was done by hand via Jenkins, and rollbacks were difficult, and it often just required extending the maintenance window or declaring an incident. So how we started with we just started with 2 teams in the POC phase that allowed us to tweak our Packer configuration, refine pipelines through deployments, and configure proper permissions and controls. As we're deploying to some of these environments such as GovCloud and our on-premise, InfoSec and compliance are always involved, so having a good RBAC model within the tool that we're using is very important. We developed our own internal onboarding documentation, just using a Git book. It was actually deployed via Spinnaker, and it still is. And the step-by-step project guides were actually based on the Spinnaker docs, so that the teams could actually see and use the application that they were learning how to build their Spinnaker pipelines from. We also did try a Docker-based deploy where we would pull down a Docker image on the bake instead of using RPM. We only got a few services using that due to we didn't invest too much time into it. Pipeline templates, there wasn't really a big story around this at the time, and we were unsure about the open source sort of future of it, because DCD and other tools, there was always discussion about what the next one was going to be. So we actually wrote our own little Python tool that would convert YAML and take in best practices that we thought and create the pipelines for our engineers. And then we developed a production checklist that we would have to go through with InfoSec, compliance, and the heads of their teams to just make sure that they were ready to go into production with Spinnaker.
So now, like after kind of the changes that we had implemented, and after kind of onboarding a bunch of the services onto Spinnaker, this is kind of like a view as to like, this is our build workflow now. So the fundamentals of it are still the same. Like git commit leads to a build in Jenkins, and we run the unit test in Jenkins, and then that triggers that then triggers Spinnaker to start its pipeline. This image shows kind of some other, like another test coverage section that is actually triggered later in our Spinnaker pipeline. And then we have some artifact repositories that not only do like our image scanning, but like vulnerability scanning and some other compliance related scanning. So then our actual like Spinnaker pipeline comes from the Jenkins trigger. We bake an AMI, and then we kind of go through our different environments. So we have like dev, we go to development, and then we have like our QA, and I put like a ... staging, because we have like different performance environments. And I guess the one difference between a lot of teams' pipelines would be just the order or kind of hierarchy of how they promote their builds. So some teams are not mature enough to have like to go through performance testing, so they don't go through performance testing, but they'll go like development, QA, staging, and then staging and production are pretty much mirrored accounts. We use a lot of the stages in Spinnaker for kind of not just manual judgment, not just like having RBAC approvals, but like we do gate a lot of the promotions based on how integration tests run in Jenkins, and how they're promoted through the different pipelines. We have different deployment models for different services. So only a few services right now do canary deployments, but that's something that we want to improve and kind of promote to more. And
that's manual canaries. We're investigating Kayenta right now.
Yeah. So some of the most, I guess I just wanted to touch on some of like the most useful features that we find from Spinnaker is like, number one is like, we're constantly tweaking Spinnaker, and the fact that Spinnaker is deploying itself is is just kind of nice. Like every time we make changes to the repo, every new Packer configuration, every new configuration, or every new update or feature that comes out, and we want to enable it, it's pretty straightforward on how we can get those changes up to production, our build production quickly. Notifications, so our Slack notifications are clutch, and a lot of teams are really happy with like the amount of information that they get from Spinnaker. The nice thing is like when you walk around our office now is like almost every developer screen, like, you got two monitors. One monitor has, Spinnaker open, which is like a year ago. It's just crazy how that's totally changed. Custom webhooks, pipeline, maybe you should.
Yeah, I can speak a little bit more to this. Manual judgments we actually use a lot. Because of the Saturday deployments that we still have to do for most of our services, manual judgments come in handy for getting our artifact right up to the manual judgment, and then it can sit there and we can just wait till the release window, and then all the teams have to do is go in and prove it, which is fantastic. The custom webhooks, what we're actually using this for now is to actually send our monitoring tools such as New Relic and others, deployment stats and information from the deployment, whether it succeeds, passed. So there's a new feature that you can actually do global webhooks, so it basically creates a stage for the other teams to consume. So all they have to do is now, next to their bake or deploy, they can do a drop-down box and say, send New Relic the deployment information. So we've abstracted that away, and it's all baked into the same configuration that Sohail was just talking about. Pipeline expressions, this is how we handle our automatic rollbacks right now. So we'll run our testing suites after a deploy, and it'll look at the Jenkins job or the results from the testing, and based on the pass-fail of that, we'll actually roll back or we'll leave it. Then with our own pipelines as code, it was really nice to have the ability to lock the pipelines within the UI. This allowed the teams to just store and mutate their pipeline within their repo, but not accidentally edit something within the pipeline. So we touched a little bit on Kubernetes. As we run an on-prem product, big focus right now is to move everything to Kubernetes so we can deploy it, our entire platform, wherever, bare metal, cloud. We're investigating using Spinnaker for it. We've had a look at the V2 provider. We had a look when it was in early alpha. We're waiting for the beta update, which will be really nice to test. So the good that we found on it, it provides developers a dashboard view that they're used to with their AMI-based deployments running in our Kubernetes cluster. And it abstracts it away in in server groups, in their infrastructure view, cluster view, and they've really grown to love the UI, and it does provide them a way that they can get a lot of information without having to look elsewhere, such as the Amazon console.
Actually, another thing is like, previously everyone had access to AWS, the AWS console, and like, we have implemented stuff like using like Keycloak and or at least using, I guess, LDAP groups role assumption to like basically limit who can see what in these AWS accounts. But really what we want is to kind of totally abstract all that. We don't need that many people in AWS. We just need people, they only need to see what they care about. They don't need to see the whole picture. They just need to worry about their deployments, their applications, the information that they need to know about, DNS endpoints, where to test, where to, stuff like that.
It's all available for them. The deployments are treated as a unified version. So one of the really cool things that Spinnaker does with the Kubernetes V2 provider is that it will actually package up your configuration and your container all as one sort of artifact. So it's very easy to roll forward and roll back with the configuration changes that you've made. Previously, it wasn't like that. So you're updating, like it's sending all the manifests out. And it's really hard to work out which one's actually causing the issue. Easily emit manifest changes and events to an audit log. We have all Spinnaker logs, pipeline logs going to our logging infrastructure, so it's great to have that that nice view of it. And then annotation-driven UI. Basically, you can add annotations to your manifest to make Spinnaker do all sorts of things with it, especially just for Kubernetes. And it's good to see that they're following the model that Kubernetes is set forward, and it's really, really powerful. So the bad that we saw at first, it lacks support for Helm templating. All our Kubernetes stuff was Helm templated. So this was a little bit of a blow because it would have made when it didn't exist, we would have had to basically rewrite all of our manifests. Secret hydration, right now it's sort of limited where it's Git or S3 for storing configuration and secrets. And then my biggest issue with it is that it renders every manifest that you deploy to Kubernetes into the UI, which includes secrets, which, if you're familiar, is just a base64 encoded value, which means anyone with read access to that pipeline can see all those secrets. There's no dynamic configuration for new clusters right now or for existing clusters. We use temporary tokens that expire. It requires a full restart of CloudDriver to read in the new kube config, which is really frustrating because we don't want to have to roll over CloudDriver every 6 hours or something. And then, I'm not sure if this is still true, but RBAC for namespaces. The RBAC model in Spinnaker is quite nice, where you can limit it per AWS account, but now that we're dealing with namespaces in a single cluster, we're looking forward to if that gets included, where you'll be able to isolate teams to a namespace.
So I'll just give like a little retrospective on like kind of the how we view Spinnaker and what we've kind of learned over the past year. And this is kind of that same format: good, bad, ugly. So the good, single pane of glass view. Like, we really love the UI. We love how it organizes your product and your applications within that product. We love the infrastructure view that gives people information about their server groups, their LBs, their instance data, like user data. And we love that it removed the need for everyone to have access to the AWS console. Teams have ownership and confidence over their deployments, so they, one of the things that maybe we didn't touch on during onboarding was that when we initially started onboarding a lot of these applications, it was very hand holding, and we started with only one or two teams, and we were kind of, and it was interesting because we were building the documentation and learning from each team like what information teams needed to be able to successfully onboard themselves. But once we had that documentation, once we had that maturity within our team to kind of hand over just a little bit of information to the teams, they started onboarding themselves. So we have a Slack channel called Spinnaker, and it was interesting because after a week or two, we just started getting pings and requests from teams that we weren't even on our plan for onboarding, and they were just getting on Spinnaker themselves. They heard about it from other teams, and they were just jumping the gun, and they were be able to onboard themselves. Maybe they run into an issue here or there, but the cool thing was it was kind of like, I think Brandon had used this term in his talk, but it was land and expand. So it was like we landed it, and then everyone just started jumping on. And so our, what seemed like a daunting task of 1 year to onboard so many different services, actually we met that goal because a lot of teams were kind of insistent on moving onto that platform. As I said earlier, Spinnaker deploying Spinnaker. Another thing is teams are now able to focus more on development and not on dealing with Saturday deploys. And also the well-defined, powerful API that we've been learning to kind of interact with. Matt had written his own concourse resource. I don't know if you want to talk about that a little bit.
Basically we were able to write a concourse resource to extend it to support that CI. Really simple. And it's also, we were able to write integration tests. So basically we would have a Jenkins job that runs when we're deploying Spinnaker itself. It would call out, and we would have a pipeline as code, and it would run our pipeline.
And that was Armory. Shout out to Armory for you guys showed us it. Some of the bad stuffs we found were like, we did that, like, because the Spinnaker is so powerful and there's like so many different ways that you can set up your pipeline, you do end up with just totally different pipelines. So like some teams will have, because some people, I guess like people have because you can make it so powerful, you can end up with a pipeline that is like, 30 steps and different and split up into different pieces, and then you kind of have to navigate to kind of figure out what that developer was trying to do. So that was kind of a little bit of our fault in terms of like being able to enforce standard kind of pipelines or using the pipeline templates early, because some teams they wanted to, when they were onboarding on the Spinnaker, they kind of felt that also meant that they were going to still do things the way they did before, just using a different tool. So it ended up in like kind of very complex, very snake-like pipelines. The RBAC authorization, like we like the RBAC in Spinnaker, but there are some things that I noticed. We did notice some stuff that like we do want some, maybe a little bit more granular control over the permissions model to be able to like not view and edit, or be able to see pipelines and edit pipelines but maybe not execute them. So some things along that. We have our production account has so many instances that you can't even load it in the AWS console. Like it's like your UI gets rate limited just trying to load our account. And so Spinnaker definitely feels that. We had a lot of issues with Redis and also just like Spinnaker itself being rate limited like crazy by AWS. And then just like some small nits were like, a lot of Packer builds being left around in our AWS account. We had some Lambda functions to clean it up, but it's like, there's like random things that you'll see, like maybe like SSH key or key pairs that you don't even think about. Then we get like millions of key pairs that are generated by Packer, and we didn't even think to clean those up. But and then like updates. Sometimes when we were trying to jump to the latest version of Spinnaker, it would break. Then we'd have to roll back, and because so many people are using Spinnaker now, it's like we need a proper SLA for Spinnaker because everyone's so reliant on it. And just like, I guess maybe with the way that we're deploying Spinnaker, it was a little resource heavy, but we plan on moving Spinnaker over to our Kubernetes build cluster, and that'll give us a little bit more granular control on like how we control the replica counts of the different services and scale up only the parts of Spinnaker that we need, more resources on. And then just some of the ugly was like, and it's kind of a mixture of like, Spinnaker is not exactly built for like our deployment lifecycle. Like we feel like Spinnaker is really, really great for production. But like a lot of our teams use very interesting like branching strategies. And one thing we have with Spinnaker is like the like wildcard branches, or being able to follow like different branches in GitHub. We were looking for maybe some support around that. The fact that we do need to redeploy Spinnaker a lot of time when we're changing configuration, and I know some of that's starting to change, but that was kind of like a pain point. One of the things we had was like one thing that we would really like is like maybe a Terraform stage in Spinnaker, because now it's like we have state that applications need, but that's managed by a different platform, by Jenkins, and the state stored somewhere else, which maybe is not a huge deal, but at least there is state stored somewhere. But just the fact that it's still kind of decoupled from, you need to set up a lot of infrastructure for Spinnaker to find like the ELBs and understand that this is an application, and then move forward with kind of like deploying that application. And yeah, so like creating dummy projects for Spinnaker to be able to find if your load balancers don't match the same naming scheme, stuff like that. And then some stuff we had raised earlier. Props to Armory, because I feel like the open source documentation is not, it needs to be kind of brought up. And luckily we had some stuff from Armory, and then also we just got dirty and went into the code.
Thoughts for the future? We just wanted a few things that we've been thinking about that maybe like modular components such as a Vault extension would be really nice to hydrate secrets if they can solve it not rendering in the UI. Some stages, we mentioned Terraform, and I know that's being worked on as well as Lambda functions. Also, one thing that we were really hoping in our compliance team is maybe a security check for artifacts. Is your RPM signed? Is your Docker image signed? Maybe reach out to Nexus IQ and find out the results and catch it before it's sort of on the host, because it's really easy to remove the GPG check in a Yum repo just from the user data. So having this gating off applications before they're deployed would be fantastic. And then more deployment metrics. I don't know of anyone that's actually put a nice console within the Spinnaker UI that would allow us to see deployment metrics, because I know all that data is there, so it would just be fantastic to have a good view.
So yeah, we love Spinnaker for production workflows, and it needs work for like kind of our iterative deployment workflows, and that's something that we'd like to provide feedback and maybe work with the community to kind of help them help us in a sense.
Yes. Yeah. Thanks for listening.
Cool. Thank you.